Hello everyone. This is in continuation with our hypothesis testing problems. The next problem goes like this. George believes that lengths of stays in hospitals are dependent on the types of health insurance that people have. He asked Donna to check the matter. Donna collected data on a random sample of 660 hospital stays and summarized them in the table below. Test the hypothesis at alpha equal to 1%. Then this data is given, days in hospital, uh, which is from less than 5, 5 to 10, greater than 10. And these are all percentage of costs covered by insurance, which is less than 25%, 25% to 50%, greater than 50%. Then these are all basically frequency, or I can say the data collected by Donna. So it is actually based on her observation she collected. So we call this as observed frequency O. We call this as observed frequency O. Right. So if you look into, there are two things here which we call it as attributes. One is that this length of stay. Another one is the type of health insurance. These are the two attributes. We need to check whether these two attributes are dependent or independent. Means, is there a relation between these two, or there is no relation between these two? So such problems, we call it as test for independence of attributes. When we come across with the test for independence of attributes, we use chi-square test again, wherein these are all considered to be this 40, 75, 65, 30, 45, 75, 40, 100, 190. These are all considered as observed frequencies. These are all basically the total of the observed frequency for each category. So this is the 180 is the total for less than 25% of cost covered by insurance. This is 25 to 50% of cost covered by insurance. This is more than 50% of cost covered by insurance. Likewise, this 110, 220, 300 are the days, less than 5 days, 5 to 10 days, greater than 10 days. So thing is now to check whether these two attributes are dependent or independent. So our hypothesis will, null hypothesis will always be that the attributes are independent will be our null hypothesis, and our alternative hypothesis will be exactly the opposite of it. Means the attributes are considered as not independent. Now we will move on to the solution part of this. The given problem, as already I spoke, the given problem is concerned with the testing of independence of attributes. Hence, we will use a chi-square test. The relevant test statistic will be the same thing whatever we had seen in our previous videos, that it is calculated value is calculated as O minus E the whole square divided by E, where your O is the observed frequency and E is the expected frequency. Observed frequency already available in the question itself, the data, whatever we saw, and expected frequency, we need to calculate about this. So here, this table, whatever table we have, this we call it as a contingency table. This table is called a contingency table of having 3 rows. These are 3 rows and 3 columns. So it is a contingency table of order 3 by 3, means 3 rows and 3 columns. So in that case, the degrees of freedom for this is calculated as R minus 1 multiplied by C minus 1, where R is number of rows. We know that is 3 rows, and C is number of columns. That also we know it is 3 columns. So we multiply those two, means 3 minus 1 multiplied by 3 minus 1, which is nothing but 2 into 2, which is 4. So this degrees of freedom we need when we look for that tabulated value or the table value of chi-square. So we need to look for 4 degrees of freedom, 1% level of significance, which is given in the question. So for that, we need to look for the table value after we do the calculations. Right. Let us further move on with our solution. We'll continue with that. First, null hypothesis. The attributes. What are the attributes? Length of stay and type of insurance are independent, right? Then H1, the attributes, that is length of stay and type of insurance, are not independent. So these are the hypotheses which needs to be phrased on. Now, how do we calculate the expected frequency? For example, if I have to calculate the cell value, that is expected frequency at first row and first column, what we do is we choose the corresponding row total. Corresponding row total for this is 180. That we multiply with the corresponding column total, which is 110, divided by the grand total. Grand total is 660. So this goes with this 6 times. So 180 by 6 becomes your 30. So straight away we can mention here the expected frequency as 30. Similarly, if I want to calculate first row, second column, I choose the corresponding total, which is row total, which is 180, corresponding column total, which is 220, divided by the grand total, which is 660. This goes with this 3 times. So 180 by 3, it becomes 60. So let us mention here 60. Now, this we need not calculate because this total needs to be 180. This is 30 plus 60, 90. That 90 will be subtracted from 180, so we get 90 directly. We need not calculate like this. Straight away, we can make it as a balancing figure. Now coming here, if I want to calculate the expected frequency of second row, first column, we need to choose the second row's total, which is 150. First column's total, which is 110, divided by the grand total. This goes with this 6 times. So 150 divided by 6. So it becomes, what do you call, how much it is? 6 2s are 12, 6 5s are. So it is 25. I can fill up here. Now I need not calculate this. I can just add these two, subtract it from 110. Adding 30 and 25 gives us 155. 110 minus 55, it is 55 again. So I can fill up here 55. Right. Now, let us calculate this expected frequency for the second row, second column, which is, what is the second row total? It is 150. Second column's total is 220 divided by 660, which is the grand total. This goes with this 3 times. So that means 150 by 3, which is 50. So we can fill up here 50. Now, rest are all we need not calculate. 110 is the total of 60 and 50. That 110 will be subtracted from 220 to get 110 as the expected frequency. Same way here, 55 is the total of these, 75 is the total of these two, 25 plus 50. 75 has to be subtracted from this 150 to get 75 as the expected frequency. So same way here, if I add these two, it is 165. 165, if we subtract it from 330, we get 165 only. So we got all the expected frequencies. That is 60, 30, 60, 90, 25, 50, 75, 55, 110, 165. Now that we got expected frequencies, we already have observed frequency in the data given in the question itself. Now we can calculate this O minus E the whole square by E. So let's proceed with our next slide. So here we have the first observed frequency. First observed frequency is 40 and the corresponding expected frequency is 30. So it becomes 40 minus 30 the square divided by 30. Then next observed frequency is 75 minus 60. 75 60, the square divided by the expected frequency, which is 60. And then the next observed frequency is 65. 65 minus 90, the square divided by 90, plus, what is the next? 30 minus 25. 30 minus 25, the square divided by 25, plus the next observed frequency is 45. 45 minus 50. So 45 minus 50, the square divided by 50, plus, what is the next? 75 minus 75. So 75 minus 75, the square divided by 75. And the next observed frequency is 40 minus 55. 40 minus 55. Then the next 100 minus 110. Let me once again check this. Is it 40? This is 1 1 1 2 1 3 2 1 2 2 2 3. This is 3 1. 3 1 is 40. Here 3 1 is 50. 100 110. Okay. Then 190 165. 190 165. The square divided by 65. So here, first one, if we look into, it is 40 minus 30, which is 10. 10 square is 100. 100 by 30. So we get 3.33. Then 75 minus 60, which is 15. 15 square is 225. 225 by 60, we get 3.75. Then 65 minus 90, which is actually 25. 25 square, negative 25. Negative 25, if I square it, I will get 625. 625 by 90 is 6.94. Then next is 30 minus 25, which is 5. 5 square is 25. 25 by 25 is 1. Then this is again minus 5. Minus 5 square is 25. 25 by 50 is 0.5. Then the next one is 0. The next one is negative 15. Negative 15 means 225. 225 by 55, we get 4.09. Then the next negative 10s, the square is 100. 100 by 110, we get 0.91. Then the last, which is 25 square. 25 square is 625. 625 is 165. We get 3.79. I'm rounding off everything to 2 digits. And then if I add this, what do we get? 3.33 plus 3.75 plus 6.94 plus 1 plus 0.5 plus 4.09 plus 0.91 plus 3.79. We get to 24.31. Now, the tabulated value or table value at 1% level of significance at 4 degrees of freedom. So we need to go and refer to the chi-square tables for 1% level of significance, which means 0.01 and 4 degrees of freedom. We get to 13.277. This is 13.277. So now we can conclude or come to an inference, since chi-square cal, which is what it is, 24.31, is greater than chi-square tab, which is 13.277. We reject null hypothesis, means we accept alternative hypothesis. Means those two attributes are not independent. That is the conclusion what we are going to take. In case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.